Hi, very good evening to everyone. Now let us study about the concept of squeeze theorem. So what is squeeze theorem? If f of x less than or equal to g of x less than or equal to h of x, when x is near E except possibly at E, and limit x tends to f of x and limit x tends to h of x is going to approach to a limit L, then obviously the person in the middle, who is that? His limit extends to g of x, is also going to approach the limit L. So this rule, we are just squeezing this g between f and h. That's why it's called squeeze theorem. So whenever these two fellows are taking the same values, obviously the middle fellow will also take the same limit L. So we'll just see a very classical example for squeeze theorem. Show that limit x tends to 0, x square into sine 1 over x equal to 0. So how do we find this? First, let us note that if we split this as limit x tends to 0, x square into limit x tends to 0 sine 1 over x, then what happens is it's not possible to find the limit for limit x approaches 0 sine 1 over x. Why? Because the limit doesn't exist for this sine function. So this is not possible with the product rule of limit. So how do we approach squeeze theorem now? We use squeeze theorem to find a function f smaller than this g, because when we consider this question as g, we are going to find a function f which is going to be smaller than g, and we are going to find a function h which is bigger than g, such that both f of x and this h of x approaches 0. Now we know the sine rule, like the range of sine function is -1 to +1, okay, for any value of x. Therefore we can see sine 1 over x also takes the values between -1 and +1. Now when you take any x square which is going to be greater than 0, that means x square is a positive number, and we are going to multiply this with the inequality, so the resultant will not change. That means when you multiply here all these places with x square, then you will see minus x square less than or equal to x square into sine over x 1 over x less than or equal to x square. So we got this right. Now when we take the limit for all this, what happens here is limit x tends to 0 minus x square, and limit x tends to 0 plus x square, the value becomes 0. So this is very important. So we just take this as function f of x, and the other one, the positive x square, is h of x, and the middle one is g of x, which is x square into sine 1 over x. Now we are applying the squeeze theorem. So as we know, this f of x and h of x approaches to 0 as x is closer to 0, then by applying the principle of squeeze theorem, we can say limit x tends to 0, x square into sine 1 over x is equal to 0. So this is how we prove the result x square into sine 1 over x approaches 0 as x is very closer to 0. That means the limit value for this function is going to be 0 as x is closer to 0. Now how can we describe this as a picture? You can see this picture. So the upper half of the x-axis, you can see the positive the parabola, which is y equal to x square, has been drawn in this way, and you can also see the parabola y equal to minus x square, which is drawn below. And what is this? This is nothing but the function x square into sine 1 over x. So you can very well see at this point all these three people are same. That means they squeeze together, and obviously you get the sine function multiplied with algebraic function x square will be approaching 0. So this is how you get the answer, and you can see this graph. It's going to be easy for you to understand, right? Now let us look on to another example. We're going to use squeeze theorem to show that limit x tends to 0, square root of x cube plus x square multiplied with sine pi over x equal to 0. So again, you can just have a look on this function. When you split it, you can see sine pi over x does not have any limit because it does not exist. So we are going to apply squeeze theorem. So we know very well that sine function will take any values as a result between -1 and +1. So that is the range, right? So when you take any x which is going to be greater than 0, and we take the question function which is considered as square root of x cube plus x square, as per the question, we are just taking that and multiplying with this inequality. The resultant will not change. So when you multiply this with negative, you get negative quantity here. In middle, you get this multiple as well as the other one, which is the positive side, right? And as we see, these two functions, we call it as f of x and h of x. When you take limit x approaches 0, it's going to be 0, and same case for the positive side. So when we take that as f and h, obviously the middle person, who is g of x, who is going to be sine pi over x into square root of x cube plus x square, is going to be 0. That is true. It holds good by using the principle of squeeze theorem, right? Now you can see this picture which is going to describe this squeeze theorem rule. The orange line you can see, which is nothing but the square root of x cube plus x square, and the green line you can see here, which is nothing but minus square root of x cube plus x square, and the blue one, who is this fellow, he is nothing but square root of x cube plus x square into sine pi over x. Now all these three people converge at a point which is going to be 0 because it is at the origin. So I hope this gives you an idea about how to apply squeeze theorem to find to show the limit for the function given here, right? All right, now let us look on to some more functions. An interesting one which is called signum function or sine function. What is the signum function? So it is just defined by SGN or sine x. It's not the sine in trigonometric function, it is SGN. SGN of x equal to -1 when x is lesser than 0, 0 when x is equal to 0, and +1 when x is greater than 0. Now we are going to sketch the graph for this function, and we are going to find some limits. So here we call the first case is going to be signum function for x when x is approaching 0 from the positive side. Here signum function for x when x is approaching 0 from negative side, and x is approaching 0. And what about the limit for signum function? And what about the absolute value of the signum function when x is tending to 0? Now we see this picture very clearly. This point at x equal to 0, you can see this signum function takes 0, as we know very well about that, right? And when x is greater than 0, you can see your y, that is f of x, is 1. When x is lesser than 0, this portion, you can see the value of y is -1 here, okay? So from this graph, when x is going to approach this origin 0 from the left hand side as well as from the right hand side, so what will be your limits you have to find? So obviously you can see from this, when x is approaching from the left hand side towards your 0, what happens is it is going to be very closer to this 1. That's why the answer is going to be +1. When x is going to be approaching from the negative side, that means the left hand limit for 0, then it is going to approach the -1. Actually this is -1, so it's -1. I hope this is clear, right? But when x is tending to 0, and what is signum function of x? So now it is very clear by a rule. Whenever you can see the left hand limit and right hand limit, if it's gonna be same, then the limit x is for x tending to 0, sine x approaches the limit. But what happens to this case? You have different numbers, plus 1 and minus 1, which is not going to be same. Therefore, the limit for signum function x when x is closer to 0 does not exist. Now, what is the case for limit x tends to 0 modulus of signum function of x? So here, whenever you take the absolute value of signum function, when you substitute the values for x, which is going to be lesser than 0 and greater than 0, whatever values you substitute here from the left hand limit side, we approach, from the left side we approach 0, or from the right side we approach 0. The absolute value is going to give you a positive value always. That means whenever you put a negative value, it becomes positive. Here, when you put a positive value, it becomes a positive value. So obviously the answer for this question here, what happens to the negativity here, it becomes positive. Okay, so it becomes plus 1 in this case. So that is why you're getting the answer as limit for absolute value of signum function is going to be 1. I hope this is very clear. And of course at x equal to 0, this function is going to be 0. Okay, that is a different case, right? So I hope this is clear for you, what is signum function. Now let me discuss about some more concepts of what is, how to find the left hand limit and right hand limit for a split function like this. So whenever you have a split function like this, f of x equal to x square plus 1 when x is less than 1, and f of x equal to x minus 2 power 2 when x is greater than or equal to 1, we are going to find the limit for f of x when x is tending to left hand side 1 and f of x when x is tending to right hand side towards 1, that is right hand limit. Now, does this limit for x tends to 1 f of x exists? And they're asking to sketch the graph for it, right? Now, let me show you the first case. Question number A. Limit x tends to left hand side 1, f of x from left hand side 1, f of x is equal to, we're just substituting when x is lesser than 1, what is the function here? X square plus 1. So substitute this 1. So what will happen? Here when you substitute, it doesn't mean that you are substituting the value of 1, it is just closer to 1, so we are just taking approximately is going to be 1, right? So it will be 2. When x is approaching from the right hand side, so what will happen to your function? So when x is greater than 1 or equal to 1, this function is x minus 2 power 2. So when you substitute 1, you will get minus 1 square, which is positive 1. But at x equal to 1, you can see here very well, f of 1 is going to be just 1 minus 2 power 2, which is going to be 1. Now, what happens to this criteria? They're asking, does this limit exist? It does not exist. That is the answer. Why? Because the left hand limit and right hand limit, what we have found is going to be different here. You can see very well. And that is not going to be equal to the limit for the function. Okay, even though you have at x equal to 1, the value of f of 1 is 1. That is a different case. So here, left hand limit, right hand limit, they are not same, therefore the limit does not exist. Now here you can see the graph of the function. So you can see these two curves, how this curve is formed. I have just written the question here. When x is less than 1, it is x square plus 1. So when x is less than 1, this is the curve you have. And you can see this point which is not, considered. That means x equal to 1 is not considered. That's why it is open here. But whereas you can see when x is greater than or equal to 1, at x equal to 1 again, this point is going to approach the value of x. Here you can see it's going to be 1. Okay. So, 1 minus 2 square is minus 1 square, which is plus 1. And greater than 1 again, you can see the curve is moving towards this side. So for all these cases, we are going to consider x minus 2 power 2. And this is the picture of our function. I hope this picture is very clear for you, right? Yeah. So I think there is no doubts in this problem. Thank you so much. We will discuss some more problems later.